Hi guys, welcome to another quick video on the Feed Scroll Generator for Autodesk Inventor. This time we're looking at how you can create a shaft to precise in-feed bottle pitch and out-feed bottle pitch. So what do I mean by this? Let's just take a look at this AutoCAD DWG. So we've got a spec for a shaft that we want to build. The bottle pitch on the intake is 59 mil. And the bottle pitch at the discharge at the end of the shaft is 147 mil. And here's the shape of the bottle. We're just using a plain circle here, but as you know from the other videos, we can sketch any shape of bottle that we want in Inventor. And here's the spec of the shaft: 120 mil diameter and 70 mil on the internal diameter. So let's head back to Inventor and we'll look at creating this, if I can remember those numbers of 59 and 147. So what we're going to do is to hit the generate button as usual, and then we'll spec our shaft up first. So I'm just going to choose a shaft length. This isn't massively important in this case for this example, but I'll go for 600. And my ID was 120, wasn't it? I can just about remember that one. And if I want a shaft ID of 70 mil, I better define my bottle shape first, hadn't I? So I'm just going to hit this edit bottle shape button here, and we just wanted a circle for that, so I'm going to delete that geometry. I always leave this center point in here, remember. I'm just going to type in 50 mil for the bottle shape. Now that's going to fall over, but when I hit the generate button again, I can rebuild that bottle, and there's the new bottle shape there. So in order to get that bottle perfectly on the center of the diameter, I could just type in 60 here, and then we are going to be cutting in 30 mil each side, which will give us an ID of 120 minus 25 times 2, so that will give us an ID of 70 mil there. So let's head back to Inventor. And then the in-depth bit is getting the bottle pitch to be correct. So now what we have in the app, version 1.005 of the app, is we're still inputting bottle velocities here. We can't directly input a pitch for the bottle start and the bottle at the end, but what we can do now is check dynamically what the pitch is going to be. So I wanted an input pitch of 59 there, didn't I? 59 mil. So heading back to Inventor, what I can do is reduce this, and you can see that the bottle pitch is changing as we're reducing that. Now what I've got to be a bit careful here with is my lead in before the bottle speed starts changing. Because my start and my end are going to be different here, I need to make sure that I've got enough of a lead in so that the bottle speed is constant across, for in this case, the first 200 mil. So the bottle speed is going to be constant for 200 mil, then it's going to be changing for 200 mil, and then it's going to be constant again if I put my lead out for 200 mil there. So I can just be confident that the pitch isn't changing during the first pitch measurement here, if you see what I'm saying. So with that in mind, let's just change this down until we get to 59. So you see we're not going to be able to necessarily get it exact, but I can see here it's somewhere between 78 and 79. So if I try 78.4 or 78.5, we're getting there. 59.03, that's about as close as we're going to get, but I think you'd agree that's pretty close. If you need it more accurate than that, then give us a buzz and we can get you 2 decimal places on there. That's not a problem at all. And then for the discharge bottle pitch, we wanted 147 there, didn't we? So let's take a stab at 200 millimeters per second for this. And let's just try reducing that down. So let's say we're watching this number here. There we are. So we've got an end pitch of 147 and a start pitch of 59, or very close to 59 there. So now it's just a case of deciding whether we want the bottle to rotate, which in this case we don't, so we're just going to untick that, and what accuracy we want. So I'm going to go with a sort of a medium medium sort of accuracy, medium to high sort of accuracy here, and I'll choose I'll move this slider here for a nice, because we've got a nice simple bottle, I'll just create fewer surfaces rather than having lots of surfaces along here. I could do a preview at this point, but I'm pretty confident if I hit smooth build, then it's going to come out right. So we can see it processing at the bottom there. Rather than waiting for this all to go through, you can see that's it's about 6% done already. It's not going to take too long, but I'll speed the video up at this point so I don't bore you guys. Right, so I've gotten back from my coffee break. This shaft's built in just over 4 minutes, 264 seconds. So I can finish that. If I want to now, I can check the spec of the shaft that I've built. I can check that the bottle pitches are right, and they are what I told them to be. Also checking accuracy using the simulate button. We've got another video for this, but if I just save this file, I'll quickly show you on this part, just because it's good fun. So I've got my shaft here, and I can drag the bottles along and see what happens to them as they're moving along the shaft there. So we can see the bottle pitch at the end is 147 mil. I can see the bottle pitch further back down the shaft here is 59.03 mil. Okay, and if we needed to spit out a step file or something like that at any stage of this is an assembly file here. There's nothing stopping me saying file, save as, or export a step file, or whatever I need to. And I can also do some accuracy checking if you're interested in that. For this particular part of the software, then you can do some 2D silhouette and 3D interference checking here. Check out our other video on our YouTube channel for instructions of how to do that. Okay, hope you find this very useful. Thanks for checking us out. Cheers, bye.